The purpose of this last video in the series dealing with distance formula and midpoint formula is to assist you in making sure that you understand the concepts. There are 4 problems in this video that you're asked to do on your own, and then to check your answer to make sure you're doing it right. And that'll show, do you understand the distance formula and do you understand the midpoint formula? So the first 2 problems we're going to do is find the distance giving a set of points. So do remember the distance formula is represented as the square root of x2 minus x1 squared plus y2 minus y1 squared. So when I plug everything into the formula, my x2 is -4, my x1 is 7, so I have -4 minus 7 squared plus my y2, which is 9, minus 8 squared. And so underneath this, I know -4 minus 7 is -11. So I have -11 squared, 9 minus 8 is 1, so I have 1 squared. Well, -11 squared is 121, and 1 squared is 1. So really I have 121 plus 1 in the square root. So my distance is the square root of 122, which is approximately 11.05. And that is the answer. So we follow the same process for the next example. We're asked to find the distance between 11.8 and 1.1. So again, start with the distance formula for it. And then what we're going to do is just plug in our corresponding values for x2, y2, and x1, y1. So my distance is equal to the square root. x2 is 1, and then x1 is 11, so 1 minus 11 squared, plus y2 is 1 minus y1, which is 8 squared. So 1 minus 11 is -10, so you have -10 squared. 1 minus 8 is -7. Well, -10 squared is positive 100. -7 squared is a positive 49. So really your distance is the square root of 149, which is approximately 12.21. And there is our distance formula. So make sure you have your radical. That's going to come in handy when we start going into further lessons, and the decimal approximation for it. Now let's look at our midpoint problems. So the midpoint problems, we have another formula for midpoint we use, and that formula is that the midpoint of a segment is represented by the coordinate found by adding the x values and dividing by 2, and adding the y values and dividing by 2. And so we go right to the formula. x1 is 8, x2 is -3. So instead of writing down plus a -3, adding negative is subtraction, so 8 minus 3 over 2. And you have y1 is 9. You're adding -4.5, so that means you're subtracting 4.5 over 2. And we go from there. Really, 8 minus 3 is 5. Now 9 minus 4.5 is 4.5. But 4.5 is really 9 halves for it. And so to go through and finish, we have 5 divided by 2, leave it as a fraction. And we have 9 halves divided by 2. And so if you have 9 halves divided by 2, you have 9 fourths. And so the midpoint is represented by the coordinate 5 halves and 9 fourths. Same idea, we're asked to find the midpoint given 2 endpoints. So we have our midpoint formula. And we're just going to plug in and simplify from there. So we have 11 as our x1. So 11 plus x2, which is 1. So you have 11 plus 1 divided by 2. And you have 8 plus 4 divided by 2. 11 plus 1 is 12. 8 plus 4 is 12. So really I have 12 divided by 2, which is 6 for the x, and I have 12 divided by 2, which is 6 for the y. So the midpoint is represented by the coordinate 6, 6. So these are 4 quick examples on applying the distance formula and applying the midpoint formula. Hopefully you find it helpful and you understand the concept before moving on to the next lesson.